let's do this problem, the longest increasing subsequence. Given an array, and we need to return the longest increasing subsequence. Subsequences can be no need to be subarray. You can jump from, as long as the sequence is the same as the original array, you can choose them. The longest subsequence in this example, it will be 2, 3, 7, 101. For this one, it will be 0, 1, 2, 3, and this one will be only 1. Because we are looking for the longest increasing subsequence, this problem can breaking down to smaller problems. So we will using the dynamic programming approach to breaking the original problem to smallest one until it reaches the base case. And this is a basic approach. So we will define a DP array, which means we'll by ending this position, for example, ending 9. What's the longest increasing subsequence until to this position? After we compute all the ending position about along it ALS to this position, we will iterate all the DP, find the largest one. It's the answer, longest increasing subsequence. The problem will start to how can we find the position, for example, in this 7 position, what's the longest one? The approach is to looking for the previous DP array, choosing the largest one, and if the integer of that position is smaller than 7, for example, the previous 2, 5, 3, they both less than 7, and we can choose the largest one from the DP of this position, and +1 denote the longest increasing subsequence at this position. The time and space complexity will both be O of n. N square. The time will n square because we will looking the previous each element to check if the element is smaller than the current one. So the time complexity will be n of O of n square, and the space, it will be O(n). We create additional DP array to recording the longest increasing subsequence until including this position. So first, let's create a DP and length of the input. And we fill all the elements with 1. Now we do the transactions. Okay, define the final result. We will loop each element inside this DP. Result is the largest one. Return the result. Okay, now we need to iterate. I is to the first one. This is our out loop. The in loop will define another variable as long as it's smaller than the current position. if the numbers at that position is smaller than the current position, we can at the current one will be the max of the current one, and 1 plus the previous one, previous longest subsequence. In this case, we build the DP array. Let's try run it. It seems works. So yes, I think that's it. The key idea is to compare with the previous one, to combine the previous longest increasing subsequence, add one to the previous one, and to mark it as the current one, and at last we iterate all the longest increasing subsequence in the DP array and choosing the large one. That's our final answer.